Okay, in this video, what we're going to do is calculate the empirical formula for a particular compound, and this would be literally the easiest kind of empirical formula problem that a chemistry student would encounter on a test or a quiz. And so in this case, what we're given are literally the mole amounts of the elements and asked to find the empirical formula. So as an example, in this problem, we're going to have 0.01950 moles of barium. And we're also given 0.03899 moles of bromine. So we're given the moles of two elements. These are not mass units. These are actual mole units. And the significance of that is that since we're given mole units, we're already in units of particles. So the reason this is the easiest kind of empirical formula problem is because literally we're already prepared to take a mole ratio. And what that means is that we're going to inspect both of these values and ascertain which of the two is smaller. In this case, it's definitely the barium. There's less moles of barium than there are bromine. So we're going to divide both values by the smaller of the two. So I'll put a fraction bar under each one. Under each one of these. And we're going to divide by the smaller value. So I'll write 0.01950 for the barium. And we'll be dividing this value by also 0.01950 to find the mole ratio. And obviously for this one we get one barium. And for this one we get 1.999 mole ratio for the bromine, all right, which is actually equal to 2. This one equal to 1. So the formula of the compound is going to be Ba Br2. Now, I want to, and this is the empirical formula. Now, I want to point out something. The student who's with it realizes when the problem was set up that we had a metal being combined with a non-metal. So the student who's with it realizes that we're dealing with an ionic compound. In the problem setup. And if you're with it, you realize that barium is a group 2 cation. So its formula when it ionizes is going to be Ba+2. And the bromine is out of group 7, and when it ionizes it forms bromide, or a -1 anion. And when these two things combine, it has to combine in the formula that we've got here. So remember, in the case of an ionic compound, the empirical formula most often is also the molecular formula. So in this problem, we have not only found the empirical formula for barium bromide, but we also found the molecular formula.